In this video, we're going to be talking about our SI units, which stands for System International. Now, these are the units that are generally accepted across the world that subscribe to SI units. We have all sorts of different things for all sorts of different types of parameters and objects and things that we want to define. So in the electronics world, some of the things that we're going to be looking at is a couple of different ones specifically. So the ones that we're going to deal with the most is going to be power, reactance, current, and voltage. We will dip into some of these other ones, but generally, mostly what we're going to be looking at is those four. So the idea behind these SI units is that we want to be able to communicate effectively with our counterparts wherever they are at. So one of the things that we look at is how can we describe something using a symbol that everybody's going to know what it is. So in this instance, some of the things that we're going to be looking at is we have units and we have the thing or the SI unit of what it's measured in. So the biggest thing that we have to look at is this distinction. Am I talking about a thing or am I talking about the unit that it is measured in? They're not exclusive. We can be talking about the unit in reference to the thing. We can talking about the thing in reference to the unit, depending on how we want. So that just because we're talking about one doesn't mean the other one isn't still there. But the biggest thing that we have to look at is to decide, is it a thing or is it a unit? So first thing that we're after is we're going to be looking at the thing. So in this case, I am looking at a voltage. It is the actual voltage of the component. I'm looking at the current. I'm looking at the impedance. I'm looking at, a capacitor, the capacitance of things. So I have this thing versus unit, because if we look, right here we have a capital C designates capacitance, but it also can designate as a coulomb. So when we first get to this, we have to figure out exactly which one is which. And that's going to determine what our symbols are. So the good thing is when we have a unit for the thing, we don't have a repetition of the symbol. Same with the unit that it's measured in, we don't have a repetition of those symbols. So we don't have to worry about coming between these, we just have to worry about jumping back and forth between the thing or the unit. So voltage is kind of a special case. Voltage, we designate it as a capital V. So if we're talking about a voltage supply, we're going to call it V1 or V2 or our VBAT, whatever it is, like for battery, things like that. This is going to be the symbol that designates a voltage source of some kind. Now, each of these are going to be measured in a unit. So V1 may be measuring in a voltage of 15 volts. So here, this V is designating the unit versus the actual thing itself. V2, we could have it designated as 24 volts. And our battery would be something like 1.5 volts, whatever it may be. So as long as we can understand, are we talking about the thing? Usually we then label them with different subscripts. Or are we talking about the unit, which usually doesn't have subscripts, and how it's measured? That is going to determine what it is. Now, I know voltage is kind of a bad example because it uses V for both of them, but it's also an easy one. Voltage is V. We don't have to worry about it. Another example is if I was using capacitance. So if I'm looking at capacitor 1, capacitor 2, capacitor 1, here is the designation symbol as C. It's being designated as the thing, kind of also being noted by our subscript. We could also just call the capacitance in general. It's something that we're looking at, a device. A capacitance is measured in farads, which is designated with an F. So C1 has a value of 150 microfarads. So here, that farad is designated as a unit. This capacitance is the thing. So I'm going to look at my two sides of the list to determine what it is. And same with I was looking at charge. If I had a charge, is going to be designated as Q1. The charge of that capacitor is going to be 150 microcoulombs. So this capacitor could be 150 microfarad capacitor, and it has a charge of 150 microcoulombs. So as long as the C is being used separately, that's how we can determine what those values are. And going forward with that, this is a list that's going to be in the notes. I would highly recommend downloading it, having a copy of it ready to go, and being able to understand and look at it and use this as a reference. I'd even print it off too and have this list of them standing next to you while we're going through the first few weeks of school. And the first few weeks of the material as we discuss it. It will help. It'll make life easier. And then this kind of stuff will start to become common practice. It'll become part of your normal language. And when we discuss these, you'll know exactly what we're talking about.